All right. 2.2, derivative of a polynomial function. So we have several rules here and we will go over them. If we have, the first one is constant rule. If we have f of x equals c, where c is a constant, like any number, it can be 3, 5, 10, right? Then the derivative of it will be 0. If you have f of x equals 3, then the derivative of it is 0. So next one is, these are the shortcuts, right? Without doing the limit, how can we take the derivative of a polynomial function? So we're going to follow these shortcuts now, okay? So power rule, if you have f of x equals x to the power of n, where n is a positive integer. If you have f of x equals, let's say, x cubed, how would we take the derivative of it, okay? So this is how the rule goes. For x to the power of n, so you take the exponent n, drop it to the front as a coefficient, and you decrease the exponent by 1. Okay, so let's apply it to x cubed. You take 3, drop it to the front as a coefficient, 3x, then decrease the exponent by 1. 3 minus 1 gives you 2. So next rule is constant multiple rule. If you have f of x equals c times g of x, the derivative of it will be c times, so you keep the constant, g prime. So you take the derivative of g. So let's say we have f of x equals 3x squared. Okay, so where c is 3 and g of x is x squared. When you take the derivative, you keep the constant 3, and then you have x squared as a g of x, take the derivative of that. So take 2, drop it to the front as a coefficient, x, decrease the exponent by 1. 2 minus 1 gives you 1. This is equal to 6x. Another rule is sum rule. If you have if f of x and g of x are differentiable, and if you have h of x equals f of x plus g of x, then the derivative of that will be f prime of x plus g prime of x. Okay? So let's say we have h of x equals 5x to the power of 4 plus 4x squared. So we can consider 5x to the power of 4 as f of x, and 4x to the power of 4 as 2 as g of x. Then when you take the derivative, you take the derivative of 5 times x to the power of 4, which is, you keep the constant, so take the exponent, drop it to the front as a coefficient, decrease the exponent by 1, so you get 3. Plus is a plus. Then again, you have 4, keep the constant. So you take the derivative of x squared, so drop the exponent as a coefficient in front, x, decrease the exponent by 1. 2 minus 1 gives you 1. So basically this is going to be equal to 20x cubed plus 8x. The next rule is difference rule. Again, f of x and g of x are differentiable. So if you have h of x equals f of x minus g of x, then the derivative will be f prime of x minus g prime of x. So let's say you have h of x equals 2x cubed minus 5, where f of x is 2x cubed and g of x is 5. Then we take the derivative of 2x cubed, keep the constant, take the exponent, drop it to the front, and then decrease the exponent by 1. So 3 minus 1 gives you 2. And derivative of 5, so that is a constant rule, 0. So you end up with 6x squared. So let's look at some examples here. So determine the derivative of f of x for each function. So you have f of x equals -5. So that's a constant. So derivative of it will be 0. Let's say you have f of x equals 6 times square root of x. Okay, so we said that you keep the constant. Well, to be able to do this, write the radical first with a rational exponent. Okay, now take the derivative. So keep the constant 6. Now we're going to take the derivative of x to the power of 1 over 2. So you take the exponent, drop it to the front as a coefficient, keep the base, decrease the exponent by 1. So 1 over 2 minus 1 gives you negative 1 over 2. So your final answer should be without the negative exponent. So that is 3 times x to the power of negative 1 over 2. That is same as 3 over x to the power of positive 1 over 2. Or you could write it as 3 over square root of x. Okay, so next one. We have f of x equals square root of 6x. So difference between b and c. Okay, you can see that for b, 6 is outside of the square root, and with c, 6 is inside of the square root. So I'm going to write this as square root of 6 times square root of x and go from there. Okay, now square root of x can be written as x to the power of 1 over 2. Okay, so now we are going to take the derivative. I'm going to do it here. So f prime of x equals, so square root of 6 is a constant, keep it. Take the derivative of x to the power of 1 over 2. Again, drop the exponent to the front as a coefficient and decrease the exponent by 1. 1 over 2 minus 1 gives you negative 1 over 2. Again, get rid of that negative exponent. So square root of 6 over 2 and move this to denominator, x to the power of 1 over 2 or square root of x. D, f of x equals negative 1 over 6 times x to the power of 5. Okay, so x to the power of 5 is in denominator. So this, so you cannot do this derivative. So I'm just going to say first what it is not equal to. Okay, this is not equal to negative 1 over 6, 5 times x to the power of 4. Okay, we don't do it because see that x, the variable, is in denominator. So we first move x to the power of 5 to the numerator, but keep the number there, right? 6 is in denominator, keep it there, and write it write it with the negative exponent. Now take the derivative. So keep the constant negative 1 over 6. So drop the exponent in front, negative 5. Decrease the exponent by 1. Negative 5 minus 1 gives you negative 6. Then write it with positive exponent. That gives you 5 over 6 x to the power of 6. So next one. So we have y equals 3 minus 4x plus 4x cubed. So we're going to use sum rule and difference rule. So derivative of 3, 0. Derivative of negative 4x. So keep the constant negative 4. Decrease the exponent. So what is the exponent for x? It is 1, right? So you drop it to the front and then decrease the exponent by 1. So actually this is equal to 1, as you see, right? X to the power of 0 is 1. So 1 times 1 is 1. So it is, you get negative 4 from here. So whenever you have, let's say, negative 4x, derivative of it is negative 4. If you have 6x, derivative of it is 6. or if you have 10x, derivative of it is 10. Okay, so then you have plus 4, keep the constant. So drop the exponent 3 to the front and decrease the exponent by 1. So if you simplify this, you get negative 4 plus 12x squared. So let's look at the next one. So y equals 2x plus 3 times x minus 1. So as you see, there's a product here. There's a multiplication, 2x plus 3 times x minus 1. So this derivative is not equal to derivative of the first bracket times derivative of the second bracket. Okay, this is not what it is equal to. So what are we going to do here is that, well, later on in the chapter 2, we are going to learn product rule and quotient rule. Then you could apply the product rule here. Okay, but for now we don't know it, so we are going to expand the brackets first. So if you do that, you get 2x squared minus 2x plus 3x gives you x minus 3. And now take the derivative. So derivative of 2x squared, 2, and drop the exponent to the front, decrease the exponent by 1. And derivative of x is, we talked about it, right? If you have 10x, derivative of it is 10. If you have 4x, derivative of it is 4. So if you have x, derivative of it is 1. So it is 1x, right? And derivative of 3 is 0. So you end up with 4x plus 1. So later on, actually, you will skip this step, and then you can directly write this. So what you do, basically, you multiply the exponent by the coefficient in front and put it there, and decrease the exponent by 1. Okay. So next one, we have this. There's a division. Again, so there's a special rule for it's called quotient rule. So later on, we're going to learn it. But for now, we don't know it. So this is not equal to derivative of numerator divided by derivative of denominator. So we cannot do it. Again, there's a certain rule to do the, called quotient rule to apply. But so you don't know it yet. Therefore, we are going to divide each term by x first before we take the derivative. So 2x squared divided by x gives you 2x. Negative 4x divided by x, negative 4. 3 pi divided by x, 3 pi over x. And you have square root of x divided by x. So I am going to simplify these two terms again before take the derivative. Okay, so 2x minus 4. So I can write 3 pi over x as 3 pi times x to the power of negative 1. And I can write root x over x as, okay, so root x is x to the power of 1 over 2, and x is x to the power of 1. So you subtract the powers. 1 over 2 minus 1 gives you negative 1 over 2. So plus x to the power of negative 1 over 2. So now we are ready to take the derivative. Derivative of 2x, 2. Derivative of 4, 0. Derivative of this, so keep the constant. So 3 pi is just a constant. It is just a number. So 3 pi, keep it. So drop the exponent, negative 1, x, and decrease the exponent by 1. Negative 1 minus 1 gives you negative 2. Plus, take the derivative of the last term. So negative 1 over 2 is the exponent. Drop it to the front. X, decrease the exponent by 1. So negative 1 over 2 minus 1 gives you negative 3 over 2. Now let's simplify. So 2, negative 3 pi times x to the power of negative 2. So we don't want negative exponent. Move it down. And this one is negative 1 over 2, again, we cannot have negative exponent, move it down, x to the power of positive 3 over 2. Okay, second page. Example 2. The height of the ball after it is thrown upward can be modeled by the equation h equals negative 4.89 t squared plus 8.09 t, where h is the height of the ball in meters and t is the time in seconds. Determine the speed of the ball as it hits the ground. So let's remember from chapter 1, the velocity of an object, it can be calculated by taking the derivative of the position function relative to time, right? So in chapter 1, we used s functions as position function, and this one is h function, same thing. It is all still a position function, okay? So we are going to take the position function, derivative of the position function h relative to t, that will give us the velocity function. Okay, so let's do that first. So again, so velocity function is the derivative of h function, which is the position function here. So now we're going to use a shortcut. So keep the constant negative 4.89. So take the derivative of t squared, but drop the exponent and keep the base, decrease the exponent by 1. 2 minus 1 is 1. Plus derivative of 8.09t is 8.09. So this gives you negative 9.78t plus 8.09. Okay, so now you can calculate the velocity at for any given time, right? You can just sub in this velocity function and calculate it. However, for this specific question, they are not giving you the time. So it looks like you have to calculate the time, right? It says determine the speed of the ball as it hits the ground. So now you have to calculate where the ball hits the ground, okay? So means when it hits the ground, the height is 0. So we are going to substitute 0 for height. And solve for t. So it looks like t is a common factor. So we get two t's. So one is 0. The other one is, so if you solve for this, you get 8.09 over 4.89, which is 1.65 seconds. So basically, looks like the motion of the ball is this. So when time is 0, height is 0. And when time is 1.65, the height is 0 again. So this is time in seconds, height is in meters. So we want to know the velocity here, and that is equal to the slope of the tangent at this point. Okay, so now we can take that time, sub in the velocity function, and calculate. So negative 9.78 times 1.65 plus 8.09. And if you do these calculations, you get negative 8.05. And velocity is in meters per second. Let's look at example 3. It says determine the points on the graph y equals x squared times x plus 3, where the tangent is parallel to 48x minus 2y equals negative 6. Then write the equation or equations of the tangent or tangents. Okay, so again, so they are not giving you, they are not asking you find the tangent at x equals this or x equals that, right? So looks like you will have to find those x values like the previous question. Okay, so yes, we can find the derivative function to get the slopes. So to get the formula for the slopes, then we will have to calculate those x values. Okay, so let's do the derivative first. So there's a multiplication here, x squared times x plus 3. Again, you do not know the product rule yet. Therefore, you have to expand this first and then take the derivative. So drop the exponent, 3x. Decrease the exponent by 1, 2, 3x squared. Plus, I'm going to use a shortcut here, multiply the exponent by the coefficient 6 and decrease the exponent by 1, x. So that is a derivative function. We can calculate, we will be able to calculate the slopes using this derivative function. Okay, but let's look at this question, right? It is saying we need the tangents or tangents parallel to this line. Okay, so looks like we have to get this information from here. So first, then let's isolate y from here to calculate the slope of this line, right? So negative 2y equals negative 48x minus 6. So you can divide everything by negative 2 and you get 24x plus 3. So slope of this line is 24. Okay, if the lines are parallel, right? The parallel lines have the same slope. They have the same slope. So then the tangent or tangents must have the slope of 24. Okay, so then I can, this is the slope formula, so I can substitute 24 here to see where the tangents have a slope of 24. Okay, so 24 equals 3x squared plus 6x. So 3x squared plus 6x minus 24 equals 0. So looks like 3 is a common factor. So factor that out. Now we can factor x squared plus 2x minus 8. That will give us x plus 4, x minus 2 equals 0. So x equals negative 4, x equals 2. So it looks like when x is negative 4, slope of the tangent is 24. When x is 2, again, slope of the tangent is 24. So now we are going to write two equations. Looks like, because we got two x values. When x is negative 4, we are going to have y equals 24x plus b. And when x is 2, another tangent, y equals 24x plus b. Okay, so we need the y coordinates of those points. The negative 4. So sub in the original function, right? You can use this x squared times x plus 3, or you expanded it and you can use this function that will give you the y coordinate of that point. So when you sub in negative 4, so you get negative 16. And when you sub 2, so 2 cubed is 8 plus 3 times 2 squared. So that will give you 20. Okay, so let's use those points to calculate for the y-intercept of those lines. Negative 16 equals 24 times negative 4 plus b. That will give you 80. Okay, so b equals 80. So y equals 24x plus 80 is one of the equations. And the other one is 20 equals 24 times 2 is 48 plus b. Looks like b is negative 40, negative 28. So y equals 24x minus 28 is the other tangent. So I'm just going to sketch this so that it makes sense to you. Okay, so if you look at the original function, that is a cubic function. There's a double root at 0 and another root at negative 3. So negative 3 and 0 is a cubic function with a positive leading coefficient, starts from quadrant 3 and ends in quadrant 1. There's a double root at 0, it bounces off. So you have such a cubic function. So if you were to draw this line, right, 24x plus 3, something like this. Okay, so we found that at x equals negative 4, maybe somewhere here, okay, negative 4, and at x equals 2, slopes of the tangents are same as this y equals 24x line. So as you see, these three lines are parallel. Okay. Okay, and we got that the equation of this line is y equals 24x minus 28, and equation of this line y equals 24x plus 80. Okay, let's look at the last question. Given that f of x equals x cubed minus 7x, determine the equation of the tangents that are perpendicular to x plus 5y minus 30 equals 0. Okay, so again, let's find the slope of this line. We will need that, right? So if you isolate y from here, so you get, well, that's 5y equals negative x plus 30, and y equals negative 1 over 5 plus 6. Negative 1 over 5x plus 6. So the slope of this line is negative 1 over 5. But we need perpendicular tangents. So perpendicular is going to be negative reciprocal of negative 1 over 5, which is 5. So we want to find the tangents that have slope of 5. Okay, so let's get the derivative function. So 3, move it to the front, decrease the exponent by 1, 3x squared. So derivative of negative 7x is negative 7. So now, again, this is the function for slopes of the tangents. So we want that slope to be 5. So we get 12 equals 3x squared equals 4, and x is plus and minus 2. So it looks like we have 2 points, right? And if you draw tangents through those 2 points, slopes will be 5. Okay, then let's write those 2 equations. So when x is 2 and when x is negative 2. Okay, so we need the y coordinates of those points. Sub in 2 cubed is 8 minus 7 times 2 is 14. We get negative 6. Negative 2 cubed is negative 8. Negative 7 times negative 2 is positive 14. Gives you 6. Y equals 5x plus b. Y equals 5x plus b. Let's calculate b. The negative 6 equals 10 plus b. b is negative 16. 6 equals negative 10 plus b. b equals positive 16. So the equation of this tangent is 5x minus 16. And this one is 5x plus 16. If we were to sketch this one, so x is, oops, x is a common factor, so you get x squared minus 7. So you have roots at 0, positive and negative root 7, and it's a cubic function with positive leading coefficient. It's gonna look like this. So negative root 7, positive root 7. Okay, and we got that at x equals negative 2. And x equals 2. Okay, so we have 2 lines. So we got this line being y equals 5x minus 16. And this one y equals 5x plus 16. And those 2 lines are perpendicular to what was the line? This one, negative 1 over 5x plus 6. Maybe something like this, okay? So as you see, these 2 tangents are perpendicular to that line.